Hey, this is our final video on inverse functions, although the ideas will be used in the following sections. This one's just going to talk about how we graph inverse functions. And it actually comes from a pretty neat trick. Okay, so the first thing is to notice that if f of x equals y, then f inverse of y equals x. That should hopefully be kind of straightforward because we're just undoing what we did before. So if f of x outputs y, so it takes x to y, then the inverse function is the function that takes y to x. So it does the opposite. And another way to see it is just straight up from the definition. If you prefer that, if we have f inverse of x, f inverse of f of x, then we know that that equals f inverse of, we're saying that f of x equals y, and we know that the composition of those two also equals x by the definition of it, of being an inverse function. So we get the f inverse of x equals y. And now we're going to ask, what does that imply for a graph? Well, if f comma f of x, or maybe we'll say x comma y, is on the graph of f of x, then it better be the case that f of x comma x or y comma x is on the graph of f inverse of x. Okay, so essentially this is saying that we have a line of symmetry. It just depends on which line of symmetry it is. And this is symmetry about the line y equals x, meaning that x and y are interchanged. So to find the graph of f inverse of x, just reflect the graph of f of x across the line y equals x. So what this is saying is that if we have a graph, we can dot in the line y equals x. And let's draw in some invertible function. So that is some one-to-one function. So maybe something that looks like x cubed. Maybe this is x cubed plus 1. So that's f of x. And now I will try not to botch the reflection. But it's going to look something like this. So what we have is if you tilted your graph about at a 45-degree angle, then you could have just folded your line. right across. And so on this line, the 2 points that touch are the ones that don't change. And it actually turns out, even though this drawing doesn't look like it, the distance away from these lines this is the same distance. And this idea that we're just reflecting across the line y equals x also helps us see why we need to pass the horizontal line test. So if we have, let's dot in the line y equals x again, and we'll draw a parabola. Yeah, we will draw a parabola. So we have this parabola in red, that's f of x. And then we take its reflection across this line. So we'll get a green function out of it. And it'll look something like that, which is not a function, since it doesn't pass the vertical line test. Therefore, we still need to be one-to-one. All right, happy graphing. See you later.